previous part of solution for 12C, we define what is sigma x, sigma y, and tau xy, both side and magnitude, and how to form the angle theta. That the most critical before we apply the equation. So it's not about the equation, not about the calculator, how to get the information correctly to input for those equation. So now the question go back to here, determine the normal and shear stress on the plane AA of the point. So from that, we just apply the equation that we have. So with the analytical method in this case, so normal stress on plane axis, how we determine that? So normal stress on plane AA. So use equation that we already have, sigma x apostrophe equal to, you don't have to memory, yes, it go to the note or go to the reference data cards. You have sigma x over sigma y over 2 plus sigma x minus sigma y, and you see that there is a pattern that you can be able to remember. Cosine 2 theta and then tau xy sine 2 theta. And now we already have everything. Sigma x negative 1400 psi, sigma y positive 1000 psi, tau xy negative 500 psi, and then theta equal to negative 53.1 degrees. So we can plug in sigma x apostrophe, plug in here. We have negative 1400 plus 1000 divided by 2 plus negative plus negative 1400 negative of the plus, so negative 1000 over 2 cosine of 2 times negative 53.1 degree, and you can see that, and then plus tau xy negative 500 plus negative 500 psi for tau xy, and then sine of 2 theta, so you have 2 of the angle negative 53.1 degrees. And now use your good calculator. You can find out sigma x apostrophe equal to the first one, first component negative 200 psi, second component equal to, with that cosine negative, that it cosine, that cosine it negative, so it become positive 334.8, and then the tangent that it will be equal to 480.1. So finally we have the equation sigma x apostrophe equal to 615 psi, and that is the first answer we have. So that is the normal stress on plane AA. Of course, the next will be the shear stress. Shear stress on plane AA. So apply equation again. We have tau x apostrophe y apostrophe equal to, go to your reference on the notes, you have sigma x minus it negative at the beginning, sigma y over 2 sine 2 theta, and then plus tau xy cosine 2 theta. Everything already have, so we just plug in tau x apostrophe y apostrophe equal to negative 1400 subtract 1000 divided by 2 sine 2 times negative 53.1 degree plus tau xy is negative 500 cosine of 2 theta. So we have it 2 times the angle is negative 53.1 degree. So from that we will get the first component. Use your calculator again. We have tau x apostrophe y apostrophe. First component we get negative 1152.4. The second component we get is 139.5. And from that one, as you can see, we have tau x apostrophe tau x apostrophe y apostrophe equal to negative 1012.9 psi. And that is the second and the last answer that the question asks. So your equation is not difficult, but how to define the sigma x, sigma y, tau xy from the stress blocks, and how to, especially how to find the angle theta is very critical. So this problem considered very critical. That's why I start this early, so that you can have all the concept before you even be able to practice on other problems in today's lesson.